LJ Institute of Engineering and Technology. Today we start with unit number 3, that is control structures. That is divided in a two part. First part is decision making statements. So let's start with that part.
Hello students, welcome to all of you. Now today we start with the practical session for a if-else theory. So we discussed the first program. Write a program to check the given number is positive or negative. So according to the title, we have to input only single number of any type. Right now we are taking integer kind of data for a number. So write integer and one variable that stores the value, that is a. Now after declaration part, the clear screen is there to clear our previous output. Now clear screen. After clear screen, we have to write printf and scanf in our program. Whatever we are writing in a double inverted in a printf will be printed on our output screen. So here I am writing enter a. So this message will be displayed on our console. Now scanf function is used to take a input from the user, that is in a double inverted you have to write %d. When you are inputting integer value, then %d. Here int indicates it is integer, so here %d. Suppose you are writing float, then %f, and suppose you are writing character, then you have to write %c. Clear? So right now %d for entering one value of kind integer, and then end of a, the name of variable. After that we have to apply our theory, that is if else. Inside if you have to write condition, and the condition for positive negative is what? Suppose a is greater than 0, that is our condition. Then go inside this curly bracket and print the message printf. In a double inverted you have to write a is positive and semicolon. Each and every statement in a void main has a semicolon at the end. Clear? After if you have to not pass the semicolon here, because it is in a syntax. After if you have not passing any semicolon. Now after completing if, you have to write else. Start, stop. Now suppose this condition becomes false, then always the else part is executed, and same line you want to copy, then edit, copy. The shortcut is control insert, and then paste this value. The shortcut for a paste is shift insert. So a is what now? Negative, because it goes on a else parts. So negative. So our logic is completed, and now last is always get ch. This function is used to display our output on our console. Clear? So this is the logic how to apply if else theory in our program. That means if this condition a greater than 0, you are giving value of a, and suppose that value is greater than 0, that indicates this part is executed and the message is displayed printf a is positive. But suppose this condition becomes false, then else part will be executed and the message is displayed a is negative. Clear? Now this blue screen is nothing but our editor, that is our Turbo C editor, at which we can write our program. Now how to execute our program? For that you have to press Alt F9. Here the conversion is done, and now the error is 0, 0. That indicates your program is perfect. If you are not knowing the shortcut key, then you can choose from this menu the compile, and then here the compile is there. Clear? There are two options. Now to run the program, again the same, you have to run from the run menu, control F9 shortcut is there, or directly press control F9, that execute our program. So this black screen is nothing but our output screen. that called console. Here the message is display enter A because I am writing in a printf. Suppose I enter A equals 10 or 12 something, then the message is display A is positive. Clear? So this is the logic for our program. Same program we are executing, control F9 with a negative value, suppose -6. Then what happened? The message is display A is negative. Clear everyone? So our logic is what? Whatever we are entering in a value, that is checked in a if condition. If it is greater than 0, then this part is executed, and if it is false, then else part, that means this printf message is display. Clear? Now same logic we are applying for another program, that is write a program to check the given number is even or odd. Now same you have to write here integer a printf scanf, that call our input. So now check the condition for even and odd. For finding even number, you have to find first the remainder. The remainder is finding using modulo operators, that is already completed in our chapter 2. If you are writing here divide by 2, then our logic is wrong, because even and odd number is decided according to the remainder. If the remainder is 0, that indicates it is even number. So the logic is modulo by 2 equal 0, then the given value, that is A, is even number. But suppose this condition becomes false, means remainder is not 0, then goes on a else part and the message is display A is odd number. Clear? Now same logic we are executing, alter F9, that is compile, control F9, that call run. Now suppose I am entering 12, then the message is display A is even number. Clear? And suppose same logic we are running another value, suppose 5, then print the message A is odd number. Clear? Suppose you want to print here the value instead of A, then what you have to do? Here you have to put %d. That means integer value here they can write, and which integer value they have to write, that is specified by comma the value of A. Same logic here, instead of A is of which kind? Integer. So you have to write %d, and then in %d which value you have to put? The value of A, that is specified. So now the output we can check. Here enter A, suppose I given 23, then the message is changed now. A is odd number? No, now it's changed with a 23 is odd number. So you can put direct value or variable as per your choice. Clear? Now same if else theory we can try for a next program, that is write a program to find roots of equation ax square plus bx plus c. This logic is already completed in our algorithm and flowchart. We cannot write a square here because superscript subscript is not possible, so you have to write like this: x into x, that call x square, b into x, that call bx. Clear? So how you can find the roots of this equation? For that, first you have to input three value a, b and c. So here three variables you need, a, b and c, that is integer a, b, c. Now how many value you want? Printf a comma b comma c. So here write enter a comma b comma c. Now three value you have to take from the user. So 3 times %d is there. How many times? 3 times. Here %a, %b, %c. So first value that you enter will be stored in a, second in a b and third in a c. Now apply the logic for finding roots. So first starting from a if is not there, first you have to find the delta. So here the variable is d. So the equation for finding delta is d equals b square minus 4ac, that is b into b minus 4 into a into c. That is formula for finding delta. Now according to the d value, delta value, you can find the roots. So if d is greater than equal to 0, then roots is possible, that is x1 and x2. Clear? So here we change the logic. But suppose d is negative, then go on a else part and print the message, that is roots are not possible, roots are imaginary. So we have start with the direct else part. Suppose the d value is less than 0, that is negative. So it goes on a else part and print the message, roots are imaginary. Clear? Now suppose d is greater than equal to 0, then what happen? There are two roots are possible, that call x1 equal and x2 equal. x1 and x2. So first you have to apply these two variables in an integer. So comma x1 x2, two variables that store the two roots. Clear? Now formula for finding roots is what? Minus b plus under root delta. Now under root is not possible here again. So for that you have to apply the function sqrt that finds the root, under root. For delta, that is this, minus b plus under root d by 2 into a. So here I am writing the formula. So this part is there, one bracket is there, and second divide by 2a. Same formula you have to apply for a x2. So you can copy it in a edit, the copy option is there. Now here you have to paste, so paste is there. Clear? Now instead of plus, the sign is changed, minus b minus under root delta by 2 into a. These two are what? The roots, x1 and x2. Now you have to print these two value in our output screen. So the printf message is used, printf x1 equal percentage d, comma, in a printf always the double inverted is there. So x1 percentage d, then x2 equal percentage d. Double inverted completed, comma, first value you have to put x1 and second value you have to put in a percentage d, that is x2. Clear? Now this sqrt function need another header files. There are two header files we are included here, that is stdio.h, conio.h. Standard input output header file and console input output header file. But this function requires another header file. How you can check which header files you need? Then put the cursor before s and then click on a right click. So they here they show the math.h is required. So you have to add another header file first here, has include math.h. Clear? Now whenever you are performing division operation, then always the answer is in a float. That is already discussed in our type conversion method. So the point value is accepted with which data type? Float. So here we can change float. When the data type is float, now the percentage d is not there, now percentage f must be required. So instead of percentage d you have to change percentage f. Same here, x1 and x2 again float, so percentage f, percentage f. Now this is our logic to find the roots of equation. First find the delta according to the input a, b, c. Now if the d value is greater than 0, then two value will be calculated and that will be printed, x1, x2. But suppose delta is negative, then it goes on a else part and prints the roots are imaginary. That is our logic. Now execute this program, alter F9. No error is there, but suppose you are missing this header file. Comment indicates this line is not executed in our program. So whenever you are executing this program without math.h, then it can show the error. But here I am including that, so the error is not displayed directly 0 0. Now execute this program, control F9, enter A, B, C. Suppose I entered 2, 3 and 4. So the message is display roots are imaginary because our delta value is negative. Clear? Again I check for another output, that is 33, 4 and 2. Then roots are again imaginary. So you have to give the value that is greater than 0. D is greater than 0. So b square minus 4 into A into C. So obviously the B is greater than, and then you can find positive value for D as per our logic, because B square. So B is always greater than A and C. Then and then you can get D greater than 0 and if part is executed. So run the same program. Here A is 2, B is 33 and C is 4. Now we are getting two roots, x1 and x2. x1 his value minus 0 point something and x2 that has minus 16 point something. Clear? So this is the logic how to find the roots and how to apply the if-else theory in our coding. This is the if-else theory. If you have any query in this practical session, then you are feel free to contact me. Thank you so much for listening this video.